In section 1.3a, used the Pythagorean theorem and found answers in decimal form to square roots. Today you're going to simplify square roots, which means you're going to find exact answers to Pythagorean theorem problems using square roots. Okay, so there are some properties that we need to go over. There are two properties we're going to go over today. One is the product property, and the other one is the quotient property. Now, math is a lot about rewriting in order to simplify and also in order to solve. So what we're going to do today is some rewriting. And what we're going to do is break square roots up. So when you have square roots, you can rewrite square roots. So I can rewrite 200 as the product of 10 times 2. I can rewrite 27 as, or if I have the square root of 27 times the square root of 3, I can put them both under one square root sign. As long as they both have a square root sign, I multiply what's underneath. Now we call what's underneath the radicand. And then I can put them together and simplify and make it 9. Now you may wonder, why did they break it up into 100 times 2 instead of something else? Well, the answer is, when we are breaking up square roots, we only want to break up using the numbers that are perfect squares. So you may want to list the first 10 perfect squares off to the side here like I did. If you can recognize them, it makes it easier to break them up. And I'm going to show you two different ways that you can simplify square roots. So the first way is by using the product property. So let's go down here. I have the square root of 20. Now, when I break up 20, I only want to use numbers that are perfect squares. So they broke this up as the square root of 4 times the square root of 5. Now the product property allows me then to break this up and say square root of 4 times square root of 5. Now the square root of 4 is 2, so my final answer simplified is the square root of 5. The number under the square root, which is called the radicand, needs to be as small as possible. Now we're going to do the same thing with 63. And if I look at my list, go down my list here, I can break up 63 using 9. So it would be 9 times 7. Now you can jump from this step to this step. They're just showing you that you're breaking it up on rewriting 63 as 9 times 7, and then using the product property to break it up into square root of 9, square root of 7. And then we can change the square root of 9 just to the number 3. So it's 3 square roots of 7. Okay, number 3. I could break this up into 8 times 10, but that's not going to help me because I can't take the square root of 8 and square root of 10 without getting a decimal. So I'm going to go back to my list here, and I'll keep going down until I find a number, 16, which is in my perfect squares. So I'm going to rewrite 80 as square root of 16 times 5, and then I'm going to break those two up. So it'll be square root of 16, square root of 5, and then the square root of 16 is just the number 4. So it's 4 square roots of 5. So that's using the product property to break up square roots and simplify. The next thing that we're going to do is we're going to do the product property in the reverse way. We're going to multiply two square roots together and then simplify. So let's see what happens here. We can put them both underneath the same square root sign. So square root of 3 times 12. That's going to give me the square root of 36. And the square root of 36 is just the number 6. Now we're going to go back up to the quotient property. The quotient property allows me to, if I have a fraction underneath the square root, I can split that up and take the square root of the numerator and the square root of the denominator. It also allows me, if I have two square root in the numerator and the square root in the denominator, to write them both, the numerator and the denominator, under one square root. So you just have to figure out which property is going to work best for you, but just remember, they go both ways. Okay, so here, this is going to be better to split them up, and the way that you know if it's better to split them up is if you see perfect squares in there. So we're going to divide square root of 64 by the square root of 25, which is just going to be 8 over 5. Now, neither one of those are perfect squares, so what I'm going to do is I am going to see if I can reduce them. So if I do the square root of 200 over the square root of 8, and then I'm just going to do this. They probably should have written it like this instead. So we're going to do it like this. And hide that. So now when I divide 200 by 8, I end up with the square root of 25, which just ends up being the number 5. Okay, looking at this one here, we have the square root of 6 times the square root of 24. I can multiply those together and then get the square root of 144. Now the square root of 144 is just 12. Much easier to read. So when we simplify, we're trying to make things easier to read. And here we have the square root of 448 and the square root of 7. Now neither one of those are perfect squares, so what I'm going to do is I'm just going to put them both under one square root sign and see if I can reduce. And I can. That turns into the square root of 64. Now the square root of 64 is just 8. And I just want to caution you, because I see this every year, that students will write the square root of 64 equals the square root of 8. Those two things are not the same. If you take the square root of 64, you're going to get the number 8. If you take the square root of 8, you're going to get 2 point something. And I don't have a calculator in front of me, so I'm not quite sure what it is. But now if I look at number 9, I can't reduce these. So instead of reducing, let's just split them up. And that's going to give me 7 over 10. Okay, that's it for today.